Well, hello and welcome to our TIPCO Analytics Forum. My name is Catalina Herrera, and today we will talk about machine learning. We will talk about responsible, accountable, and transparent AI. I welcome our two panelists, two leaders in the industry with years and years of experience applying machine learning and AI in general. We talk about applied data science and what it means to use this technology across multiple use cases in the industry. So, Dr. Thomas, welcome, and please introduce yourself. Would you like to share a little bit about your background and your experience and your part of TIPCO within the data science team and so on? So, Dr. Tom, would you introduce yourself?
Yeah, thank you, Catalina, and thank you for inviting me to this panel. I'm really very excited about it, and the topic is incredibly timely, obviously, because we've seen this incredible growth in AI, machine learning, and people-facing AI and machine learning. And so these issues are becoming critical. So for my background, I came to TIPCO through an acquisition of the Statistica product. And for those of you who know that product, you know that we've been in the business of model management and modeling at scale for a long time. And I hope I can contribute usefully to this discussion and explore some of the ideas.
I have no doubt about it. Thanks, Dr. Tom. Nora, so would you please introduce yourself and your role as part of the TIPCO data science team as well?
Yep, sure. So my name is Nora Hosseini. My pronouns are she, her. I'm a lead data scientist at TIPCO with the EMEA team. I'm based out of London. I've been working in the AI space now for almost 4 years. And before that, I was a process engineer. My degree is in chemical engineering. I was mostly working on EPC type projects. I'm one of those people who did a sort of slight technical switch because I am very passionate about things like the topics we're going to be talking about today: ethics, AI, how they manifest and interact with the users.
That's exactly why I invited you to do this, because we have the years of experience, but at the same time, the knowledge and some tips and learning lessons and so on. So let's put things into perspective, right? AI is not a new concept. I mean, we have been talking about machine learning and artificial intelligence for years. Let's think about Alan Turing already saving millions of lives with applied data science back in the early 40s, right? And by the way, if you haven't seen the movie The Imitation Game, I totally recommend it. But realistically, we have been trying to simulate human intelligence for over 60 years, as was stipulated by the McCarthy conference back in '56 during the Dartmouth conference, where I believe we were too focused on simulating human intelligence instead of augmenting human intelligence, where today I actually see the most successful AI use cases in the industry. And that's what we're going to highlight today. So Dr. Tom, you have been part of this history and the history of analytics, right? And I'm sure you have seen a lot of applied data science and AI use cases, but at the same time, a lot of, okay, lessons learned, this is what we have to do, this is how we best scale and so on. So how is data science an effective way to embrace data and AI-driven business processes at the scale at all? What can you share with this audience?
Yeah, so as I think some of you may know, in my past life, I was actually a cognitive psychologist, cognitive scientist, and we did a lot of research on how people acquire procedural knowledge, which is how do we develop our preferences. Now, interestingly, it's not done through conscious awareness. Rather, we learn things through experience by processing incredible amounts of information out there that becomes a priori, allows us to make instant judgments, instant preferences, like some people, dislike others. Data science, deep learning very much has driven in the same direction, trying to build very complex models with very complex interactions, and in the process replicate all the biases, all the problems, all the likes and dislikes for which there is no rational explanation. So I think this is why we are here today. We make predictions about valuable resources such as discounts, creditworthiness, medical procedures. And this goes on and on and on. And everyone, including myself, demand that this is fair and that no harm is done. So I sometimes told the story before in some other context, how I used to get when, I still get catalogs. So I used to get a catalog with nunchucks, swords, attack knives, which I assure you is not me. I am not that person. So somewhere I was really wrongly dispositioned, which is sort of humorous. You throw the catalog away. But think of it, someone in some database, some model had you dispositioned with a better than average propensity to buy stuff like that.
Let me highlight something there because it's important. It's the fact that AI, it's a tool and it needs to be properly configured, right? And we need to actually embrace that and what it means to properly configure the tool.
Yes,
right?
So obviously understanding the biases you're building in, differential accuracy. So it's not just representing your population appropriately, but also thinking through that you perhaps overrepresent some parts of the population in order to ensure that you're accurate. Think of, again, medical procedures, if that wouldn't have been a, nunchucks, but rather eligibility for a medical procedure that could save my life. These things become extremely important.
Yeah.
So thinking through the data that come in, making sure that I have proper representation, not just the same as in the population, but rather overrepresent in order to achieve accuracy, in order to be fair to everyone who's dispositioned is critical. And then, of course, monitor. And yeah, that's number 1 and 2, I would say. And I'm sure, Nora, I know a number of other ideas.
Yeah, let's talk about that. Nora, what happens if we don't configure the tool properly? Do we have any examples of what can go wrong with AI and machine learning applications?
Yeah, absolutely. There's so many examples, actually. And Dr. Tom, what you're talking about in your case is innocuous, right? We're talking about a catalog where they were trying to market something for you, but maybe in other situations, they would have been a lot more dangerous. And as you were saying, possibly affecting your health or your prospects or your life in some indirect way. So that's a very good point. And actually, it reminds me of, there's a movie out on Netflix. It's called Coded Bias. It is directed by this woman, Joy Buamlini. I'm sorry, I'm probably pronouncing her name absolutely wrong. She's the founder of the Algorithmic Justice League. And she was a PhD student at the MIT Media Lab working on computer vision. And one of the things that she noticed when she was programming these applications was that they wouldn't pick up her face. Her face was not properly identified until she put on a white mask. So imagine what you're talking about, overrepresenting populations is so important. It turned out, actually, they hadn't even thought about African-American women or people of other races, and also just typically genders, right? So it was overrepresented by white men. And that's why the software was working better for that specific demographic. So, I mean, it can be very consequential. Maybe in computer vision, getting people's faces wrong, so you could argue in situations like surveillance might be to your benefit, but it also might be effective in, say, self-driving cars. If a car can't identify that you're, in front of it and hit you, that's a serious consequence, right?
And just for anybody that is listening to us and that perhaps doesn't have the hands-on experience that we bring to the table, or that hasn't really understand the target of a machine learning algorithm and so on, at the end, we are building these algorithms. I mean, the data science is us trying to define a decision tree, an if then, and a mathematical representation of that sample, of that data, right? That if you have been collecting in the same way that we behave as society, well, it's going to be very easy to just transfer all of those society issues into data, right? So it's going to be biased data. It's going to be like, if you think about you as an engineer building an algorithm to do A, B, or C, you are thinking from your perspective and from me as a male or female with certain degree, with certain characteristics. then I will have A, B, and C. That is boxing us as humans, right? In a very, very specific way. So how are we going to protect ourselves now that we are digitalizing more and more and more of these samples, right? So it's important to maintain that human as part of the machine learning workflow, right?
Yeah.
So let's use the technology. We have a machine learning platform, and that's what we do. The technology is there, and we have it in our hands. That's not out. But what needs to happen for it to actually target something that is not so biased, that is not going to have such an ugly consequence after that? So what is a transparent model? What's that? Can we actually share a little bit of that with our audience? How you will describe that, Nora?
Yeah, it's a good question. And actually, I just want to touch on one point that you mentioned earlier, which is these are things that we make, right? The tools that we like. So the fact is, there are developers thinking and encoding and putting all these things into practice. So we will naturally have blind spots. And we need to remember that these are not just sort of abstract machines that just sit somewhere and they're not untouchable. These are all things, these are all creations of the human intelligence, the human consciousness that we've brought into being. So we need to remember that. And we need to remember that we're the ones who actually design these tools. They're not the be all, and they're not the final decisions, shall we say. So back to your point about the transparency is, there's a lot of talk about black box modeling. And because of, so deep learning and the concept around deep learning has been around for a long time, as you mentioned. I think it was in the 50s that the idea of a deep learning and neural networks has been around. Mm-hmm. But the only reason it's proliferated in this current moment is because of the massive amount of data that we're producing as a society, right? Whether it's on our mobile phones or on the internet, all these different places where technology has started to touch our everyday lives. That's how we've managed to amass this data to actually use deep learning models. So the deep learning models, the only one of the drawbacks with them is that they're not human interpretable. This is one element that we mean when we talk about transparency, right? How can a human understand what the model itself is doing? A lot of the more traditional techniques, so maybe the more statistical machine learning modeling techniques, they're more easy to sort of separate out. There's usually a linear element, or there's usually some way to assess what the model is doing. As you said, if it's a tree, it's like if that this. So there is an interpretable aspect to it. Mm-hmm. One of the things that we did in our AutoML platform is we purposefully did not use any of the black box types of models, mm-hmm. because of the fact that we couldn't explain this thought process and this pipeline. Mm-hmm. And we also have included an explainability template along with our AutoML process. So not only is the AutoML process fully viewable and that you can pull it apart, and that's mm-hmm. one way that it's transparent, but also you can examine the data going into your model. So you can assess, okay, well, what is informing this different modeling? Why is my data set unbalanced in some way that we're overrepresenting a specific demographic?
Right. So let me highlight a couple of things there, because there are two different things. The fact that you can actually use the technology to automate some of the process and help your team to clean and transform the data and all of that and put that in some kind of automation, that's fine. The fact that you can compare multiple models at the same time and see what potential effect that's going to be there, it's also fine. I mean, the tool is allowing you to define this optimal machine learning workflow, so you avoid those blind spots and have an opportunity to see what are the consequences of this model. So I think we have been talking about the potential of the bad, and I think I need to highlight the potential of the good as well, because this is an invitation for us to rethink the way we use our most important asset, right? Data. Because yes, we have seen the bad and the ugly, but I have also seen the good and the useful with multiple use cases across the industry, where I see the pattern again and again and again, right? Collectively, we are more intelligent. There is a lot that we can do with this technology. And especially what the industry is calling today as model ops, right? Which is pretty much, hey, how we're gonna create these models so we maximize the use of this, but still we make it scalable, right? So Dr. Tom, what are some lessons learned from the industry when designing this machine learning workflow?
Yeah, that's something, Nora, as you talked, I was thinking through about the issue of explainability. I know how we build models in this automated model building in our data science authoring platforms and Team Studio and so on, which is really a smart way of doing it. Something else I have seen and increasingly see, and is actually related to some work we've been doing and you can learn about in a What's New in Data Science session here, breakout here at this conference, and I advise that you take a look at it, is that really there is in most regulated industries, so for example, in pharmaceutical manufacturing, there's a clear distinction between trying to find out what works, number one, which is not regulated. So use your black box models, use intuition, use whatever you want, frankly. It doesn't matter because this is the creative process. And we do this as data scientists, obviously. That's when we get started. But when it comes to deployment in so many industries, you have to demonstrate not only that you understand what the prediction is, but also that those who are being predicted can understand it. By understand, I mean I can explain it to myself and I can do something about it. So then let's take credit scoring, credit default risk when you apply for a loan. The most common procedure still is, yes, they do whatever is required. We do whatever is required to build a model that's predictive. But what we deploy is effectively a proxy model, which is a linear model with linear effects, very few interactions, if any, so that if I am denied credit, I can say, here's what I need to do, more income, less recurrent debt, whatever the case may be. And then those models get locked down. And when I say locked down is in regulated industries, increasingly in all people-facing data science, these models are approved with strict approval processes. There's version control so that I can demonstrate to you and the world and ensure as the organization, because frankly, most organizations want to be ethical. They want to follow procedures that don't offend, that doesn't get them into trouble. Right? And they want to be fair because they're driven by people like us. I mean, you talked about that data science modeling starts with us. And I certainly don't want to do harm. I think most people don't. Right? So, so model ops is really the process of being able to manage, have full visibility, and we're building that out at scale now as a comprehensive solution. And again, we'll talk about it some more in What's New in Data Science.
Beautiful, beautiful. And I think you mentioned something very important. It's the fact that it's something that we're building for ourselves. So let's ensure that this is doing what we think it's doing. And let's ensure that we have in place the proper structure for it to do what we think it's going to do. So Nora, what will you say that teams can do today? So from your hands-on perspective, daily perspective, data science, applied data science perspective, what can they do today to ensure an optimal machine learning workflow that will reflect our social diversities? That's kind of part of the conversation here, right? How are we going to avoid all that trouble that we know is easy to get into?
Well, first we need to be conscious of the fact that there are going to be blind spots regardless of what we do. And we're going to try to mitigate them as much as possible. And that starts with having really diverse teams, right? So if we have, I mean, it's a shame that in technology, there aren't that many female identifying programmers these days, because actually they were the first programmers. They were the original computers back in, I think, World War II times. So it's just been a funny shift that we need to rein back in to encourage women, and not just women, all kinds of minorities, to be involved in technology, because ultimately it does affect them. Just as I was saying before, right? We create the tools. So having that voice and having that ability to alter the tool is important. Diverse teams, incredibly important. Representation of all kinds of backgrounds. So if you typically tend to hire only from the top schools, mix it up a little bit. Have people from different kinds of backgrounds. They might offer a lot more than you would imagine, just with that other perspective. An example I like to bring that's from a book that I highly recommend to everybody. It's called Invisible Women by Caroline Criado Perez, in which she dissects data and talks about data and how the world is designed against women by looking at numeric examples. She spoke of some archaeologists who dug up a skeleton and they couldn't tell if it was male or female. Something to do with the pelvis is usually the way you can tell whether a skeleton is male or female sex, right? And they had a calendar with markings of 28, some kind of 28-day cadence. And they were stumped. These archaeologists were like, what kind of calendar goes by 28 days? Meanwhile, I'm sure if they had one female on the team, they would have told them,
Immediately.
she's tracking immediately. Immediately. They would have told the team, we're tracking the menstrual cycle here. This is something that women have been doing for a long time because it's part of our daily life. And this is a perspective that will get missed when you don't have that as part of your daily life. So it's just a matter of making sure that you have a lot of different types of people, a lot of different so ages, abilities, everything around the table, creating these products, because you are going to have blind spots, and so you want to mitigate them as much as possible.
You will always, yes. And I think that's a beautiful advice. Be aware. Number one, be aware. Diversity is important. Points of view are important. And the more variables you have to represent your problem, the better. As simple as that, right? It's applicable to everything in life. So let's start summarizing, Dr. Tom. So if we have to share and a specific set of insights with these data scientists that are going through this process. And if you want to say, okay, you want to adopt a technology or a flow or a set of steps to properly evaluate projects. Like, okay, you're going to start your data science journey. You're going to define your machine learning workflow. You want to ensure that you want to properly evaluate these projects. What will be included in there? What properly evaluating these projects will include based on your experience, Dr. Tom?
Yeah, so actually the good news is that there are companies, TIBCO and companies like TIBCO, that provide the tooling to quote the citizen data scientist. You know, Nora, your point about including more women, more minorities, more everything and everybody, that's really happening and is possible because the tools are there, the quote citizen data scientist and so on. And TIBCO provides this tooling, right? The other big advice I have, and this is something I have been preaching for a long time, is every project starts at the end. So before you do anything, don't worry about the technology, because too often I see engineers suddenly, the engineering side taking over those projects, the quote hardcore data scientists who are very much in the data. It should really start with people who are stakeholders, which means the business stakeholders, the people who are being predicted. Think through, how will I use these models? What can go wrong? What happens if I am, you know, mispredicted, if the prediction is wrong? How will it affect the person?
Yes.
How do I provide the feedback? How do I make sure that whatever it is I'm predicting is perceived as fair? Is it something I should be predicting, actually? Perhaps it is something that we as a society decided we really don't want to, because we want to leave it up to the individual to decide what that person wants to do and so on. So once you know what the model is supposed to do, how we will use it, how it will be used, how it will be perceived, then go backwards from there and start building finding the right data, finding the right samples, finding the right representation, find the right models, define what explainability really means, and make sure that it is then really deployed this way, which is the way the model ops part comes in. That's sort of the summary I would have in my mind.
Love it, love it.
And if I may add,
Yep.
I just want to add something, Catalina. So what you mentioned, Dr. Tom, is really great. I also think that testing it out on a lot of different end users is important, right? For example, there is one use case that maybe you're aware of. The Apple co-founder, Steve Wozniak, was offered a much higher credit limit than his wife. And even though they have no separate financial assets, they have she doesn't have any bank accounts or anything in her own name. And in doing so, I think that Apple Card is actually missing out on a huge opportunity here, which is a growing demographic. It's an up and coming market, an emerging market, right? Women are going to be acquiring more wealth in the future. And this is just one example related to women, but I think that there's a lot of opportunities in general, regardless. So making sure that you test it out on lots of different types of end users to see maybe you're missing out a business opportunity as well as incorrectly and unfairly rating the user.
Love it. So I will say,
and even before that, as you build the model, if there were women, wives, partners on the team who build the models and see that variable in there and say, wait a minute, that has lift, that predicts something. Why is that? And is that by itself something that would offend me? You wouldn't have gotten into that trouble in the first place.
Exactly. Yeah. So we do have to be intentional. This is intentional AI. We have to be thinking about the end user driven application, right? Start with the end goal in mind. Who is going to be affected by that? Always think what can go wrong, right? Like always think 10 steps behind what can go wrong. Ethics and profits are not mutually exclusive, right? Yeah. The organizations can continue their ethics practice and just the technology is going to adjust to it. And then I will say that the closing comment is human first. I mean, this has to be a human-centered AI, right? Our goal is to amplify and to maximize our insights and to ensure that we are using the tool in the optimal way. But our goal is not to replace the human. I think the opposite. The more we can keep the human as part of the loop, the more optimal this will be, and the more we can actually benefit out of the proper use of these tools. Well, this has been phenomenal. I really appreciate both of your inputs, insights, and I hope we had a great time and great sharing insights opportunity with the rest of the community. I appreciate you too today. Thank you.
Thank you, Catalina. Thank you, Dr. Tom.
Thank you.